In 2007, one company controlled nearly half of the global mobile phone market. Its devices were everywhere, from Europe to Asia to emerging markets across Africa and South America. For millions of people around the world, owning a mobile phone simply meant owning a Nokia. But within just a few years, that empire collapsed. A company that once defined the mobile industry suddenly lost the very market it created. So what happened? Was it bad marketing, a failed supply chain, or poor expansion strategy? Not exactly, because not every company fails due to bad business decisions. Some companies fail because they fail to keep pace with technological evolution. And the collapse of Nokia may be one of the most important examples of that in modern technology history. Hi everyone, welcome back to Strategy Lens. On this channel, we explore the intersection of technology, business strategy, and innovation, and how the technical decisions companies make can shape entire industries. Today we're diving deep into one of the most fascinating collapses in the technology world, the rise and fall of Nokia. But this is not just a story about market share. It's a story about operating system architecture, developer ecosystems, and how infrastructure-level engineering decisions can determine the fate of an entire company. Because long before smartphones existed, Nokia wasn't just building phones. It was helping build the global telecommunications infrastructure itself. To understand Nokia's dominance, we have to go back much further than the mobile phone era. The company was founded in 1865 in Finland by mining engineer Fredrik Idestam. Originally, Nokia had nothing to do with telecommunications. It was a paper mill built near the Nokian Virta River. Over the next century, the company expanded into a wide range of industrial sectors, including rubber products, electrical cables, consumer electronics, and industrial equipment. By the mid-20th century, Nokia had effectively become a diversified engineering conglomerate. The real shift toward telecommunications began in the 1960s. Following a merger between Nokia's cable, rubber, and electronics divisions, the company began investing heavily in communications technology. One of the most significant technologies Nokia developed during this era was the DX200 digital switching system. The DX200 was not just another telecom device, it was a highly modular switching architecture. Instead of relying on centralized hardware, the system used distributed processing nodes, allowing telecom operators to scale capacity. And systems like these quietly powered the global communication infrastructure long before smartphones existed. During the late 1970s and 1980s, Nokia engineers also contributed to the development of early cellular networks. In 1979, Nokia participated in building early mobile radio telephony networks that evolved into the first generation of cellular systems, known as 1G cellular network. Later, the company became one of the major contributors to the GSM standard, which would eventually dominate global mobile communications. But Nokia's biggest advantage wasn't just infrastructure, it was scale. Under CEO Jorma Ollila in the early 1990s, Nokia made a bold strategic decision. The company exited most of its unrelated businesses and focused entirely on telecommunications and mobile devices. This allowed Nokia to build one of the most efficient supply chains and manufacturing systems in the industry. Throughout the late 1990s and early 2000s, Nokia became the world's largest mobile phone manufacturer. Phones like the iconic Nokia 3310 became symbols of durability and reliability. Another device, the Nokia 1100, became one of the best-selling electronic devices ever created. But hidden inside these phones was another critical component, an operating system that powered hundreds of millions of devices. That system was called Symbian. Before modern smartphones existed, mobile devices were designed very differently. Processing power was limited, memory was extremely constrained. And battery life was one of the most critical engineering constraints. Operating systems for mobile devices had to be optimized for these limitations. Symbian was built specifically for this environment. Originally developed by the British company Symbian, Symbian was designed as an embedded mobile operating system. Its architecture prioritized three things above all else: memory efficiency, power efficiency, and real-time reliability. Symbian used a microkernel architecture where only the most essential services ran in kernel space, while other services operated in user space. This reduced system crashes and improved reliability. The OS also used event-driven asynchronous processing, allowing telephony services, messaging systems, and network stacks to operate efficiently without wasting CPU cycles. This design worked extremely well for keypad-based phones. Devices with small displays, simple interfaces, and limited applications. For that generation of mobile technology, Symbian was actually a remarkably advanced operating system. But around the mid-2000s, the role of mobile devices began to change. Phones were no longer just communication tools. They were becoming general-purpose computing devices. Users expected web browsers, media applications, navigation software, and third-party apps. This meant operating systems had to support modern graphical interfaces, scalable application frameworks, developer-friendly programming environments, and large application ecosystems. And this is where Nokia's challenge began. The biggest challenge Nokia faced was not hardware. It was software architecture. Symbian had been engineered for an earlier generation of devices. Its internal design relied heavily on strict memory management techniques. For example, Symbian used a specialized system called descriptor-based memory handling to avoid memory leaks in low-memory environments. While efficient, this system made application development significantly more complex. Developers had to carefully manage memory ownership in ways that modern programming environments typically abstract away. Meanwhile, the graphical user interface frameworks within Symbian were built for keypad navigation, not fluid touch interaction. When touchscreen smartphones began appearing, Nokia attempted to adapt Symbian to support touch interfaces. Devices like the Nokia 5800 Express Music introduced touchscreen capability, but the implementation relied on retrofitting touchscreen behavior onto UI frameworks originally designed for directional keys. This resulted in inconsistent user interactions and slower software development cycles. Inside Nokia, another problem was growing: internal fragmentation. Multiple operating system projects were running simultaneously. The primary system remained Symbian, but Nokia engineers were also building Linux-based platforms like Maemo and later MeeGo. Each project had different development teams, technical priorities, and roadmaps. Instead of converging toward a single unified software platform, Nokia's engineering ecosystem became divided. The company also attempted to build its own developer platform through the Ovi Store. But the experience for developers remained inconsistent because different Nokia devices used different versions of Symbian. Application compatibility became difficult, and in software ecosystems, developer confidence is everything. Once developers start building their platforms elsewhere, it becomes incredibly difficult to bring them back. By the late 2000s, Nokia's leadership realized that the company was losing ground in the smartphone era. The operating system that once powered its success was now limiting its ability to innovate. In 2011, Nokia made a dramatic strategic shift. The company partnered with Microsoft and adopted the Windows Phone operating system for its future smartphones. The idea was to create a new platform ecosystem capable of competing in the rapidly evolving smartphone industry. But by that time, the market had already stabilized around other mobile ecosystems. Developers had already invested years of work building applications elsewhere. Without a strong developer ecosystem, even well-designed hardware struggled to compete. Nokia's market share declined rapidly. And in 2013, Nokia sold its handset division to Microsoft. The company that once dominated the global mobile phone industry had exited the smartphone race. The story of Nokia is often described as a business failure, but that description misses an important nuance. Nokia did not fail because it lacked engineering talent. It did not fail because of poor supply chains, and it certainly did not fail because it lacked innovation. For decades, Nokia engineers built some of the most reliable telecommunications infrastructure in the world. They helped develop switching systems, cellular standards, and mobile operating systems that powered the first generation of global mobile connectivity. What Nokia struggled with was the transition from hardware leadership to software platform leadership. The smartphone era became an ecosystem battle. Operating systems, developer platforms, application frameworks, and Nokia's legacy architecture made that transition extremely difficult. In that sense, Nokia was not simply a failed business. It was a company that struggled to compete in the software and IT ecosystem that came to define the modern smartphone industry. Stories like Nokia show that the technical architecture behind a product can determine the fate of an entire company. So I'm curious what you'd like to explore more on this channel. Would you like to learn more about the fundamentals of IT, how operating systems, networks, and devices actually work in real-world environments? Or would you prefer deeper dives into the technological architecture behind major companies and how IT decisions can shape entire industries? Let me know in the comments. If you enjoyed this video, consider subscribing to Strategy Lens for more deep dives into the intersection of technology, strategy, and innovation. And thank you for watching. I'll see you in the next one.